Okay, so here's a question. F of x equal to cos of x by 1 minus sin x raised to 1 by 3. Okay, in this question we need to find, look at the options. Okay, so from this question, what do we need to find? Limit of f of x when x tends to pi by 2. Okay, that's what we need to focus on. That's what we will find. Let's go. So here we have this question. We need to find limit of this f of x when x tends to pi by 2. Alright, so when we plug in pi by 2 directly, what form do we get? So cos of pi by 2, which is the numerator, is 0. 1 minus sin pi by 2, which makes it 1 minus 1 raised to 1 by 3. Essentially, we are getting a 0 by 0 form. Okay, now let's change this. Okay, so x is tending to pi by 2. I would like to convert it to a t which tends to 0. Okay, alright. So I will write this relation between x and t, that x is equal to pi by 2 plus t. Okay, alright, x will be replaced with pi by 2 plus t. So then what happens to the limit? Let's watch. So it becomes limit t tending to 0. Remember, we are replacing x with t here, x with pi by 2 plus t rather. Okay, so then this becomes cos of pi by 2 plus t in the numerator, 1 minus sine pi by 2 plus t raised to 1 by 3. Okay, so what does this further become? Right, so let's just change the color of the ink here. So here we can get limit t tending to 0. Okay, t is tending to 0, cos of pi by 2 plus t. In the second quadrant, cos is negative. Since the angle here is pi by 2 plus t, this becomes sine. So basically, cos of pi by 2 plus t becomes minus of sine t. Let's divide it by this denominator. Sine of pi by 2 plus t will be, so sine in the second quadrant is positive. Okay, that remains as it is. But since it's pi by 2 plus t, it becomes cos t. So there we have 1 minus cos t raised to 1 by 3. This is the new version of the limit that we have. Now, how do we deal with this? Okay, so you can see here, in the numerator, we have minus of sine t. I will write that as minus 2 of sine t by 2 into cos t by 2. Sine 2x is 2 sine x cos x. Same thing. Okay. And below, what do we have here? 1 minus cos t raised to 1 by 3. Very, very interesting. 1 minus cos t can be written as 2 sine square t by 2. Okay. 1 minus cos t is nothing but 2 sine square t by 2. Alright. Now, this thing is raised to 1 by 3 now. So, it's not sine square now. It's, okay, this whole thing will be raised to 1 by 3. We'll put it as it is. Okay, now how do we proceed? This further becomes limit t tends to 0. So here we have minus of 2 divided by 2 power 1 by 3. Okay, we'll just deal with the constants first. So 2 divided by 2 power 1 by 3 becomes 2 power 1 minus 1 by 3, or in other words, 2 power 2 by 3. Okay, we have 2 power 2 by 3, the constant term there as it is. What else do we have? Oh wow, we have on the numerator sine of t by 2. And in the denominator, we have sine of t by 2 raised to 2 by 3. It's sine square t by 2, sine square t by 2 raised to 1 by 3. Okay, so it becomes sine t by 2 raised to 2 by 3. Alright, now can we make this numerator and denominator interact? Sine of t by 2 divided by sine of t by 2 raised to 2 by 3. Okay, let's of course make them interact. Sine of t by 2 raised to 1 minus 2 by 3. Okay, 1 minus 2 by 3, as we all know, is 1 by 3. Okay, so that is also taken care of. Sine of t by 2. What other term is left here? Oh, here there is a cos of t by 2 left. Okay. Now, can we apply the value of the limits directly? Alright, let's find out. Can we? So, we have minus 2 power 2 by 3. Okay, then sine of t by 2 raised to 1 by 3. As t tends to 0, this will also tend to 0. Now as t tends to 0, cos of t by 2 will tend to cos of 0, which is 1. Okay, so basically our final answer is simply coming out to 0 here. Alright, so now let's mark the correct option as B here. What did we do in this question? I converted x to t. When x tends to pi by 2, t will correspondingly tend to 0. Okay, so once I replace that over here, okay, it became a matter of simple manipulation. And then we converted the angles. That was part of the manipulation. We converted the angle x to x by 2 to cancel some terms out. Okay, so with that we finally get the correct answer as 0. Got that? Okay, in this question we are given that n is equal to 2 and we'll have to find the value of this given limit. Alright, let's go. So here n is equal to 2, lovely. And this limit here, you can see it in the numerator, e power x minus 1 minus x square by 2 factorial and so on till x power n by n factorial. Alright, but n is equal to 2. We don't need to go till n factorial as such. We'll stop at 2 factorial there. Okay, divided by x power n plus 1. Okay, let's write that little neater. Okay, so I'll write this as limit x tending to 0 e power x minus 1 minus x square by 2 factorial, and I'll stop right there because n is equal to 2. Okay, so now let's look at the denominator. Denominator is x power 2 plus 1, which is x cubed. Okay, we have this much with us. Now this is our question, and how do we go about solving this? Right, you can see this x cube here. So if you put the value of x equal to 0 directly, we'll get 1 minus 0 divided by 0 cube. Okay, basically you're getting 0 by 0 form. Alright. So, what we can do here is, we can use the expansion of e power x. What's the expansion of e power x? It is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Alright. But our numerator has e power x minus 1 minus x square by 2 factorial. What is going on here? So in the expansion, you take the first 3 terms. Okay, you take these first 3 terms and bring it to the LHS. Okay, take the first 3 terms, bring it to the LHS. What are you left with? The remaining bunch of terms. Okay, so this is what we are looking for. So clearly this will be equal to x cubed by 3 factorial plus x power 4 by 4 factorial and so on. Alright, understood? You just took the first 3 terms from the RHS, took it to the LHS. That is why this question is so very easy. So it becomes x tending to 0, limit x tending to 0. The numerator here is x cubed by 3 factorial plus x power 4 by 4 factorial plus x power 5 by 5 factorial onwards. This is an infinite series. Okay, divide by x cube. Okay, so clearly there is some cancellation that's going to happen. Let's implement, right? So limit x tending to 0, x cubed by 3 factorial, or rather let's take x cube common. So we're getting a 0 by 0 form. Alright, so let's take the smallest power of 0 common. Right, that's the standard technique. 1 by 3 factorial, which is, I'll keep it as 3 factorial, plus x by 4 factorial, plus x square by 5 factorial, and so on and so forth. Alright, cancel out x cubes. And now put, so what happens now? Now the reason it became 0 by 0 has vanished. We just cancel it out. Okay, x cube is tending to 0, so you can cancel it out. Now let's put x equal to 0. Let's see what we get. We will get a very determinable value, which is equal to 1 by 3 factorial or equal to 1 by 6. Okay, so this becomes our final answer here. What did we do in this question? We simply used the expansion of e power x in the numerator. Okay, and use that to cancel out with the denominator to get a finite value as 1 by 6. So hence, let's mark B as our correct answer. Got that? Okay, in this question, we have to look for the value of this limit. Limit x tends to 0, sigma, okay, one summation is there, r par cosec square x, where r goes from 1 to n, the whole thing is raised to sine square x. Okay, let's find out what the answer is. So, here we have this complicated looking thing. Let's just expand this summation first to get a clearer idea of what this even actually looks like, right? Let's put the values of r as 1, 2, 3, etc. You can see that r will take n different values from 1 till n. Okay, so we have this much here. What I'll do right now, okay, so I notice this 1 par cosec square x, 2 par cosec square x, all the way up till n par cosec square x. I'll divide each of these terms inside this bracket. Okay, inside this bracket, I will divide each of these terms by n raised to cosec square x. Okay, so it becomes, so the next term, if I divide that by n raised to cosec square x, it becomes 2 by n, the whole raised to cosec square x. Alright, let me write that n clearly. Okay, n raised to cosec square x. Similarly, this last term here, okay, will become n by n raised to cosec square x. Now we divided randomly by n cosec square x inside the bracket. So, inside the bracket only you have to multiply by what? N raised to cosec square x. Alright. And then when you multiply the bracket by this inside, you are taking it outside the bracket after that. Okay, this n raised to cosec square x, okay, n par cosec square x, you will be taking it outside the bracket. Alright, when you take it outside the bracket, there is a raised to sine square x here. Okay, there is a raised to sine square x here. Alright, so this becomes n par cosec square x into sine square x, which is nothing but n par 1. Okay, so when you take it outside, you will get n par 1. Okay, please understand this. Alright, so every term I divided by n par cosec square x inside that bracket, and when I try to balance the equation, I have to take the n par cosec square x outside the bracket, and when it comes out as plain n. Alright, so basically this is what we were getting. Alright, that n by n raised to cosec square x, I write that as 1. Okay, because n by n is exactly 1. Alright, this is not tending to 1 or anything, this is exactly 1. So I write that as 1. 1 raised to anything, exactly 1 raised to anything is 1 itself. When it's tending to 1 and it raises to infinity, that is when it's an indeterminate form. Okay, please understand that. Next, here, let's notice that x is tending to 0. Okay, so now let's look at the par here. Sine square x will tend to 0. Okay, lovely. Cosec square x will tend to infinity. Okay, so what have we got here till now? Alright, so 1 by n raised to cosec square x. So you can see that n is there, but 1 by n. Alright, n is some number, but when I talk about 1 by n, I know that it is, look, n is a natural number for sure. Okay, it's an integer, positive integer. Now 1 by n will be between 0 and 1. That's for sure. Okay, it will be lesser than 1 but greater than 0. N is positive and greater than 1. Think like that. Okay. Now, what about 2 by n? Same. 3 by n? Same. All of these will be between 0 and 1. So you take any k by n. Okay, please note that. You take any k by n where k varies from 1 all the way up till 1, 2, 3, all the way up till n minus 1. Okay, because when k is equal to n, you are getting exactly 1. So we stop at n minus 1. That's the idea here. So k can take any of these values. Alright, and they will all be between 0 and 1. Okay, so all these k by n's you see are all between 0 and 1. Alright, they are raised to, all of these are raised to cosec square x. Raised to cosec square x. We know that cosec square x here is tending to infinity. So we take a value between 0 and 1 and raise it to the power infinite. Okay, basically multiply it with itself infinite number of times. So you take a value between 0 and 1, and multiply it with itself infinite number of times, what do you get? You get a value lesser than 1 raised to infinity. Basically, you get a value which tends towards 0. That's the idea. So all of this, okay guys, all of this, limit x tending to 0, n, okay, that lovely n there. Okay, we'll leave it as it is. And inside this, we'll get 0. So 1 by n power cosec square x can be written as a value lesser than 1 raised to infinity. It's of that form. Okay, so that is 0, 0. All these zeros are there. Plus this last plus 1 is there, right? This is exactly 1. That's why it remains as 1. Okay. If it was n minus 1 by n, it would have been lesser than 1. Okay. And that raised to the power infinity will still tend towards 0. Okay. So the last term is exactly 1. So keep it as it is. Now what's the value of this limit, guys? It's very easy. We'll get it as n into 1, or in other words, n. Okay. So the value of the limit we've been looking for is basically option C, n. Okay. The key is, what were the steps involved? So you saw all these r cosec square x's, right? I divided by n cosec square x. Alright. So this is what you summed. Okay. N power cosec square x. So it became r by n raised to cosec square x. Alright. So here r goes from 1 to n. But the thing is, we'll break it into two parts till n minus 1, and the other will be sigma r equal to, or rather just put r equal to n. Okay, that is the last part. So this is when r is equal to n, we get it as n by n raised to cosec square x. So basically in this first part, all these terms are of the form r by n. So you can see that r by n is lesser than 1, greater than 0. You are raising it to cosec square x, which is tending to infinity. So this entire part will tend to 0. What you are left with is simply this exactly 1 raised to something that's tending to infinity. Okay. If it is tending to 1 raised to infinity, it's an indeterminate form. But exactly 1 raised to infinity is raised to something that's tending to infinity is exactly 1. Alright. So that's why we conclude that our final answer, okay, will have just n. Okay, because n power cosec square x, you took it outside as plain n. Alright. Okay, look at this question. Yeah, we have to find the value of this limit when x tends to 0. Alright, let's start. So we have x plus 2 sin x in the numerator, and a difference of 2 square root signs, okay, terms with 2 square roots in the denominator. Okay, so before starting finding this limit, let's put the value of x equal to 0 and see is it indeterminate or not, right? So when we put x equal to 0, what do you get? You get 0 plus 0 in the numerator, 0 plus 2 into 0 in the numerator, and below you have root of 0 plus 1, which is root 1, minus root of 0 minus 0 plus 1, which is also root 1. Guys, what form is this? We are getting a 0 by 0 form. Alright, this is a simple 0 by 0 form. Now to get rid of 0 by 0 situations, what can we try in this context? When you see the denominator, there are 2 square root signs. Please think of one thing, rationalizing. Alright, so when we rationalize, what will this look like? So we have root of something minus root of something in the denominator. I will write that as an a minus b. So to rationalize that, I will multiply it with the corresponding a, which is root of x square plus 2 sin x plus 1, a plus b, which will be, b will be root of sin square x minus x plus 1. Okay, the same thing will come up again in the numerator. Okay, so this will be root of x square plus 2 sin x plus 1 plus root of sin square x minus x plus 1. Okay, so we have this limit in this form. Okay, so when we multiply that, let's rationalize the denominator. What do we get? We get a square minus b square form in the denominator. Basically, that square root will just vanish. We'll get x square plus 2x plus 1 minus x square minus x plus 1. So when you remove that bracket, it becomes minus x square plus x minus 1. Okay. Now, when we put x tending to 0, what are we getting now? You are getting numerator. Okay, denominator you are getting 0 for sure. Okay, this plus 1 is there, this minus 1 is there. They'll cancel out. Okay, but all other terms are x square, x, sine square x and 2 sine x. All will become 0. Denominator is 0. Okay, what about the numerator? The first part itself, there are two parts here, okay, as a product. X plus 2 sine x itself is 0. Now I don't need to care what that other remaining part is, right? Alright. So basically we are stuck with a 0 by 0 format. Alright. So what we'll do is, let's take care of this other part. Okay, let's take that limit together. So then this becomes limit x tending to 0. Okay, what do we get? So when I put x tending to 0, this becomes root of 0 square plus 2 into 0 plus 1. Okay, 2 into 0 is 0 itself. Plus 1. Okay, so we get root of 1 plus again root of 1. Okay, for this part. So this is coming out to 2 here. So this limit inside these yellow brackets, guys, this limit here is coming out to 2. So we write that limit first. Okay, so that limit came first. What else is remaining? We have x plus 2 sine x in the numerator and x square plus x plus 2 sine x minus sine square x in the denominator. And guys, you can see now we are still stuck with 0 by 0 form. Okay, nothing has changed as such. But there is something called hope over here. What do we do? Guys, what can we do here? How do we fix the situation? Alright, so when you put limit x tends to 0, you're getting 0 by 0. Let's apply L'Hopital rule. Okay, when you apply L'Hopital, what happens? If you had applied it in the first step, the question would have looked huge. Right, that numerator you will differentiate easily. The denominator, there will be two parts which will look pretty big. And what if that was still indeterminate? You'll have to do it again. Alright, so we just simplified it as much as we can and then we'll apply L'Hopital. Okay, so that's the idea here. It becomes 2. Let's take care of the numerator now. Let's apply L'Hopital to the numerator. Numerator becomes 1 plus 2 cos x upon differentiation. And the denominator, guys, x square becomes 2x, x becomes 1, 2 sin x becomes 2 cos x. And minus sine square x becomes minus 2 sin x. And then you differentiate sin x and you get cos x. Okay, this is the chain rule. Okay, so here we have so much. Okay, let's apply x tending to 0. Let's hope it's still not indeterminate, right? Let's check. When we put x tending to 0, what happens? We get 2 into 1 plus 2 into cos 0. Cos 0 is 1, so 1 plus 2 is the numerator. Denominator, x is tending to 0. 2x becomes 0. 1 remains as it is. 2 into cos of 0 is 2. Minus 2 into sine 0 into cos 0. Second you see sine 0, that part is gone. It's 0. Alright. So what are we getting, guys? 2 into 3 by 3. This is nothing but 2 here. Okay. So in this question, all we did was we simplified it a little further using rationalization. Okay. But when we did that, we were still stuck with 0 by 0. So whenever that happens, what can you do? You can try L'Hopital rule. Okay, we tried L'Hopital and we got 2, which means option B will be the correct answer. Got that? Okay, look at this problem here. Limit y tends to 0, root of 1 plus, there's another nested root inside it, root of 1 plus y power 4 minus root of 2 by y power 4, as you can see very clearly. Okay, so can you tell me what the first step would be? So you see two square roots subtracting each other in the numerator here. So let's try rationalization, right? Because when you put y tends to 0, you're getting root of 2 minus root of 2, which is 0, divided by 0 power 4. 0 by 0 form. Okay, you're getting a 0 by 0 form. So first thing we'll do is we'll rationalize this, see what we can get from here. So root of something minus root of something will be multiplied by root of that same something plus root of 2. Okay, and the same quantity will be visible again in the denominator. Okay, we have this much with us. Now the numerator is of the form a plus b into a minus b, which will be rationalized as a square minus b square. So you will get in the numerator 1 plus root 1 plus y power 4 minus root 2 square. Okay, so this is what we have. Denominator is y power 4 as it is, and the other part of the denominator will remain here. Now, if you look at the other part of the denominator, this side here, okay, as y tends to 0, how does it behave? Okay, so when we look at the first part, we get 1 plus root of 1 plus 0 minus 2, which means numerator is 0, divided by 0. Okay, so here we are clearly getting an indeterminate form. We'll have to figure something out for that. But this part, what are we getting? When we put y tending to 0, we get 1 by root of 1 plus root 1. So that is root 2 here. And then plus root 2. Okay. So basically all of this comes out to 1 by root 2 plus root 2, or simply 1 by 2 root 2. The other part here, okay, so this limit we took care of. The other part is still a clear 0 by 0 form. Okay, it is still a 0 by 0 form. We need to figure that out as well. Alright, let's do that. So we get this as limit y tending to 0, 1 by 2 root 2. Alright, and then the remaining terms here are y power 4 root of 1 plus y power 4 minus 1. Okay. Guys, this is the 0 by 0 form we are still stuck with. Okay, nothing has been solved yet. So, how do we take care of this in one go? Apply L'Hopital. Okay, so applying L'Hopital. Okay, what happens? What do we get? Let's differentiate the denominator and the numerator separately and divide both of them, right? So, this will become the same limit, y tending to 0. Let's differentiate the numerator. What do we get? Root of 1 plus y power 4 will be 1 by 2 root of 1 plus y power 4. But 1 plus y power 4 we'll have to differentiate again. Here comes 4y cube. Alright. Divided by, let's take care of the denominator now. Okay, 2 root 2 into 4y cube. Okay, this is the denominator. We just differentiated that. Wow, I can see that there are two 4y cubes here. Cancel them out. Alright, then what are we left with? There's a 2 and 2 here as well. No. They will actually multiply into each other. This 2 will remain as it is. So what are we left with here? Limit y tending to 0. Alright, so below we'll have 4 root 2 and root of 1 plus y power 4, and the numerator we'll just have a simple 1 there. Okay, so this is what we've got so far. Alright, so to find this limit, what do? Just put y equal to 0 now. So when you get y equal to 0, this becomes, your answer becomes 1 by 4 root 2 into root of 1 plus 0 power 4. Okay, this is simply equal to 1 by 4 root 2 only. Alright, all of this basically is coming out to 1 by 4 root 2. What did we do in this question? First rationalized, got 0 by 0. Once we are stuck at 0 by 0 form, applied L'Hopital. Okay, and then we moved away from indeterminate form. We got the final answer as simply 1 by 4 root 2, which means option C is the correct answer. Got that?